Alright, so hello and welcome to this video tutorial for RC Hibbeler's Engineering Mechanics Statics textbook. So we have this problem from chapter 4 here, which is asking us to determine the resultant moment produced by the forces about point O. Some of you might have seen some of my video tutorials before, and having done so, you might be familiar with this concept here, which we use for kind of decomposing vectors that have an angle with the horizontal in this way, right? But what's interesting about this problem is that we have two vectors that we're going to decompose, I suppose. So there's the section of our structure here, which has a 30-degree angle with the vertical, and there's the 300-pound force that also has an angle with the vertical. Basically, I just wanted to make a quick point at the start of this tutorial here that you might be familiar most with this way of decomposing vector quantities, where we have an angle with the horizontal. But in this case, we have an angle with a vertical. When you have an angle with the vertical, you can essentially swap these two round, right? So before, we would say that the horizontal is given by F cos theta, where theta is the angle with the horizontal. But now the horizontal is given by F sine theta. And conversely, the vertical is given by F cos theta. So when we're dealing with problems like this, a kind of short, or the way I see it, a kind of shorthand way to understand this is that, you know, these cos's and these sines kind of flip here when we're dealing with an angle with the vertical as opposed to with the horizontal. I just wanted to get that out of the way before we crack into this problem then. So let's go ahead and get started. Let's just start taking moments here. So we can say the sum of moments acting, let's say anti-clockwise, just because looking at the diagram, it looks like we're going to have a net anti-clockwise moment here. So the sum of moments acting about point O, acting anti-clockwise, is equal to, well, let's start by considering anti-clockwise moments. The first obvious one, I suppose, is F2, this 200-pound force here. The perpendicular distance there is going to be this length here, which is the vertical component of this 6-foot section here, which, based on what I described earlier, we could say is 6 cos 30. That's our perpendicular distance there. And then that's going to be multiplying our 200-pound force. The other anti-clockwise moment we have acting here is going to be the vertical component of F1 here. The perpendicular distance there is going to be this 6-foot length plus the horizontal component of this 6-foot section here. So that perpendicular distance we could describe as 6 plus 6 sine 30, right? Based on what we said earlier. Now, the force being enacted there is going to be given by 300 cos 30. Okay, 300 cos 30. And the only thing to consider left is the horizontal component of F1 here. The perpendicular distance is going to be given by this distance here, which we already know is 6 cos 30. And the magnitude of the horizontal component of F1 is going to be given by 300 sine 30. Okay, interesting problem. We have what we need now. We just need to plug this into our calculator. And when we do that, we should get a value of 2,598 pound-feet here, which we can simplify to, let's say, 2.60 kip-foot. And that's our solution there. If you have any questions or comments about that problem, please feel free to leave them down in the comment section down below. Otherwise, thank you very much for watching.